For our next transformation, we're going to talk about reflection. And you can see as reflection is a transformation that reflects or flips a graph across a line, which we call a line of reflection. Now, initially we're going to start here by reflecting our graphs or our functions across either the y-axis or the x-axis, but keep in mind that you can also reflect any figure over any given line or point over another point. So it won't just be the x and the y-axis. However, that's how we will start today. So we give you a quick visual here with the black graph being f of x, and you can see when we reflect it across the y-axis that all of the x values actually change place, and so that's kind of given to us in this little part right here. We see that when we reflect over the y-axis that the x is negated. Now, on the other side of that, if we reflect over the x-axis, the y value is negated, and you notice here we say y, or we say negative f of x, but if you recall, y is the same thing of f of x, so if we negate the y, which is what's happening in that reflection, we're also negating the f of x. So that's in effect doing the same thing. So if we reflect over the x-axis, we're negating the y, or the entire f of x function. So since reflection is something that you should have covered in geometry, I hope that this is somewhat familiar to you. And we have a sample problem for you to work. So if we'll move on down to sample problem number 2, if you go ahead and pause the video and try to work that on your own to start, and then come back in a second and take a look at the solution. Okay, so if I want to reflect this basic graph across the x-axis, I need to find the points that correspond to the given points in the original function. You can see I've listed them out in this table already. So basically, we've got 1, negative 2, we've got 2, 2, we've got 4, 2, and we've got 6, 4. So I want to reflect those basic points across the x-axis. Now, the way I'm going to do that, I'm going to simply take this point, and I notice that it's 2 units down from the x-axis, so I need to go to the other side and go 2 units up. And I basically need to do the same thing with the other points on the graph. So same, I'm going to go opposite of that, and then of course this is 1, 2, 3, 4 up, so I got to go 1, 2, 3, 4 down, and so now that reflected graph creates a mirror image of the original graph. Now, what I need to do is I need to put that information in this function, in this table representing the transformation. So the first one is 1, 2. The next one is 2, negative 2. We have 4, negative 2. And 6, negative 4. So the next question asks, how do the y coordinates of the points change after being reflected over the x-axis? And you can see here that these points in relation to those points are actually opposite values. So it's either, you could say it's either negating the values or it's making them opposite values. The next question says, how do the x-coordinates of the points change after being reflected? And you can see by looking at those values right there, there is actually no change. And so we could just simply say no change. Okay, so if you didn't have any trouble working that problem, you've got a pretty good basic understanding of reflection and starting this as we move into other parent functions.